This is a walkthrough video on how to do solubility-based questions for Year 11 chemistry. So here's my question here, which of the following chemicals will dissolve, and give a good explanation for each choice with reference to the bonding of the substance and the atoms being present. So key thing here is, the key learning that you have to take from this is, there's three things that can dissolve. There's polar things, there's some ionic things, and then there's also acids, and they all dissolve in different ways, which is what the second part of this question also asks for, which is the equation to show how this occurs. So we need to identify these substances first of all as being polar, ionic, or acidic, and then decide based on that, will they dissolve. Here's methanol, and I can see that it's got a hydroxyl functional group here, which makes it polar. So methanol is polar, and it can form hydrogen bonds with water. Again, identifying the type of intermolecular force that it will actually bond with. Because methanol is polar, it's simply going to be surrounded by water. We're going to start off with a CH3OH, and that's going to be liquid, and then when it reacts or gets involved with water, it's just going to turn into an aqueous substance. So showing that the molecule itself doesn't change, it just becomes aqueous. My next one here is lithium sulphate. I need to look at this and say, well, it's ionic because it's got a metal and a non-metal, or you can see the sulphate, that's an ion. So it's ionic. So it's ionic, but how do I know if an ionic substance will dissolve? Well, we have solubility rules for that, and I teach a group of atoms or ions which are highly soluble, and lithium is that. So lithium positive is present. So therefore, yes, it will dissolve, as lithium is a highly soluble ion. So therefore I need to now write the equation to show what happens with that. Because it's ionic, it's going to break apart into its separate ions. So lithium sulphate starts off as a solid, and when it gets involved with water, the lithium ions are going to break apart. I've got two of those, and I'm going to end up with a sulphate ion as well. These are aqueous. And it's important that you check that you've got charges on these ions, because they're no longer combined and neutral. They now have a charge attached to them. The lithium ion is +1, the sulphate ion is -2. Now I've got silver carbonate. This again is ionic. However, it doesn't have highly soluble ions, so therefore no highly soluble ions. So it will be considered insoluble, and it will not actually dissolve in water, so therefore I can't write an equation for it. Ethanamine here, okay, it's got the amino group here, so therefore it's polar, and will form H bonds with water, and that's why it will dissolve. Because it's polar, it's going to dissolve in the same way that methanol did, so CH3, CH2, NH2. And it's going to start off probably as a liquid, and it's going to form an aqueous solution when it's dissolved in water. And therefore, this is my equation to show that ethanamine, when it's dissolved in water, it's still ethanamine. It hasn't changed at all, it's just surrounded by water molecules. The lithium sulphate, however, did change. It formed just separate ions, which is interesting to note. Benzene here, I've got C6H6. That suggests it's going to be non-polar. Okay, and will not dissolve because it is non-polar. Anything with just carbons and hydrogens, that's considered non-polar because it will be symmetrical and it will have an even charge all the way around the molecule, so therefore it's non-polar. Nothing that is polar will be soluble in water. Nothing that is non-polar will be soluble in water. Okay, so therefore, if you've got molecules with just carbon and hydrogen, they will not be soluble in water because they are non-polar. Dihydrogen monosulfide is this guy here, and it's going to be looking like this. Okay, that's a covalent compound, but it's going to be a polar one because it's non-asymmetrical. So therefore, it's going to be polar, but it doesn't form hydrogen bonds. It's going to form dipole bonds with water, because only with hydrogen bonds, only FON atoms, which are bonded to hydrogen, will be able to form H bonds. Anything else is just dipole-dipole forces. The equation for this, because it's covalent, because it's polar, it's simply, again, just like our other guys. Now, dihydrogen monosulfate is a gas. You probably don't need to know that, but it's going to react and, sorry, it's not going to react, it's going to dissolve and just become aqueous by itself. So that's the first part there, ensuring you know how to identify if something dissolves in water, but also the equations and showing the equations there. Pressure points obviously are the states, making sure you have states present, and also you have charges on the ionic compounds that you're dealing with there and the ions that you're breaking apart into. The next two questions are showing a bit more detail around about how stuff dissolves. So first of all, draw a diagram to show how sodium sulphide, Na2S, dissolves in water. Identify the bonds broken and formed when this happens. So if I've got this guy, I first of all, like I did here, need to identify what type of compound it actually is. Now this one here is an ionic compound, so therefore it's going to break apart. So that means I'm going to end up with a Na positive, I'm going to end up with a S2 negative. That's what's going to happen when this dissolves. But how will it what will happen in water? It's going to form these bonds. The sodium is going to be attracted to the oxygen part of water because that's got slight charges. It's got polarity with it. So therefore the sodium ion is going to be, I guess, forming an interaction with the oxygen here. This is known as an ion dipole force. And then this other ion, the anion, is going to be attracted to the hydrogen part of water here. And this is, again, is going to be an ion dipole force as well. Okay, so I've formed ion dipole forces between my ions and my polar molecule thing there. Identify the bonds broken and formed when this happens. Well, let's have a look at this. What's going to happen in this? We're going to break ionic bonds and we're going to form ion dipole bonds. That's what's going to happen when this substance actually dissolves. Now here's another one. Draw a diagram to show how water molecules might arrange themselves around the molecule below when it dissolves in water. So I've got a molecule here. This is a covalent compound. It's actually an organic molecule. And I need to show what's going to happen with the water here. Now, these regions here, which are our nitrogen and oxygen, they're very negative regions. So therefore, I'm going to have a hydrogen bond from my nitrogen forming with my water, because it's going to be delta negative, it's going to be delta positive. Again, my water always has slight negative charges on the oxygen, slight positive charges on the hydrogen, and so therefore I'm forming these hydrogen bonds here. So I'm going to say hydrogen bonds because I want to show as much detail as possible here. And then this section here where I've got the nitrogen and the hydrogen, these hydrogens are going to be slightly positive, this nitrogen is going to be slightly negative, so therefore this hydrogen section is going to be attracted to the oxygen here, and this is where my, again, hydrogen bonds are forming. So therefore, this is what's going to happen with my molecule. I could have drawn a similar thing here happening with the oxygen, where my oxygen would form bonds with the hydrogen of water. Again, hydrogen bonds being formed here. I could have also shown this nitrogen here forming a hydrogen bond with a hydrogen from water as well, just like I have here, because this is a region of negativity. Any oxygens or nitrogens are regions of negativity. Any hydrogens which are attached to that nitrogen or oxygen are regions of positivity within our polar molecule. And that, my friends, is how we go about identifying and explaining how things dissolve.